In this video, I want to have a look at whether a function is increasing, decreasing, or stationary at a point. So first off, I just want to define those three terms. So if we have a function that has a positive gradient, we say that it is increasing. A function that has a negative gradient, we say it's decreasing. So that's our negative gradient there, or a decreasing function. And if a function has a gradient of 0, then it's not increasing or decreasing, so we call it stationary. So if it's horizontal, it's stationary. So when we're looking at a curve rather than a straight line, we're going to consider the gradient of the tangent to the curve at a particular point to figure out whether our curve is increasing, decreasing, or stationary at that given point. So let's have a look at a few examples. So we have three curves here. We're going to have a look at whether they're increasing, decreasing, or stationary. So some of them are a little bit easier to tell, but if we're not sure, we can always draw a tangent on it at that point. So up here, it's pretty easy to tell that this is increasing at this point. But if we weren't sure, we'd draw a tangent on, but this is a pretty straight line anyway, so our tangent isn't going to look like much. And we can see that the gradient of our tangent is increasing. Over here, we've got our gradient being negative, so our curve is decreasing. And right at this point, at the vertex here, if we were to draw a tangent to the curve at that point, we would end up with a horizontal line. So because the gradient of the tangent at that point is horizontal, that means that our curve is stationary at this point here. So looking at this one, our stationary points would be here and here, and that's because the gradient of the tangent at those points is horizontal, or the gradient is 0, sorry. This bit over here, the gradient of any tangent we drew to the curve in this section would be positive, so our curve is increasing here. In this section here, between our two stationary points, our curve is decreasing. And on this right-hand side bit here, we can see that our curve is increasing again. All right, this third one, if we have a look just at this little bit down here, we can see that it's increasing. If we have a look right over on the right-hand side, we can see that that's increasing as well. But what happens in the middle gets a little bit different. So if we start looking at tangents to the curve, so we've drawn a tangent at this point here, we can still see it's still increasing. If you draw a tangent at this point, we can see it's still increasing as well. But as we move closer and closer, we're actually going to get really close to 0. And at this point right here, the tangent to the curve at that point would be horizontal. It'd cut straight through. So this point here is a stationary point. So when we're looking at curves, it's relatively easy to figure out whether our curve is increasing, decreasing, or stationary at a particular point. But a lot of the time, our questions won't give us the graph of our function. Instead, we'll just be given what the function is. So f of x equals whatever it happens to be. So instead of graphing or sketching our function to figure these out, what we're going to do instead is have a look at the first derivative, because the derivative tells us the gradient of the tangent. So if we have a function, f of x, and we know that it's defined at x equals a, so a is just a number, then if we find the first derivative at that point a, so we're going to differentiate and then substitute that value of a in, if that first derivative at a is greater than 0, then that means our function is increasing at that point. If it's less than 0, our function is decreasing. And if it's equal to 0, then our function is stationary at that point. So let's have a look at some examples. So our first question says, determine whether the function f of x equals 2x to the power of 4 minus 6x cubed plus 7 is decreasing, increasing, or stationary at these three values. So the first thing we need to do before we even worry about what those values are is we need to find the first derivative. So our function is here, which means that our derivative, so f dash of x, would be, so we'd go our 4 times our 2 to get 8x, and we decrease that power, so we've got 8x cubed, minus the 3 times 6 is 18x, decrease the power, so 18x squared, and that constant term will just disappear. So this is our first derivative. Now we're going to find the value of that derivative at these particular x values. So for part A, we've got f dash 1. So we're going to substitute 1 in here. So we're going to have 8 times 1 cubed minus 18 times 1 squared, which is 8 minus 18, which will give us minus 10. So we don't actually care what the value of this is, but we do care if it's positive, negative, or 0. So because it's negative, at x equals 1, so therefore at x equals 1, f of x is decreasing because it's negative. All right, part B, we've got at x equals 0 this time. So we've got f dash 0 would equal to 8 times 0 cubed minus 18 times 0 squared, which will just give us 0. So that means that because our derivative is 0 at that point, it is, our function is stationary at x equals 0. And our last one, C, is at x equals 7. So we're going to have f dash 7 equals 8 times 7 cubed minus 18 times 7 squared, which gives us 1,862. So because that's positive, we're going to have, therefore, increasing at x equals 7. So our next example asks us to find the value or values of x where our curve f of x equals 2x cubed minus 24x is stationary. So stationary means that we want that first derivative to be equal to 0. So what we're going to do, we're going to find our first derivative. So we're going to differentiate, which would give us 6x squared minus 24. Now we want that derivative to be equal to 0. So we're going to have 6x squared minus 24 is equal to 0. And now we're going to solve this equation. So we'll add 24 to both sides. We'll divide both sides by 6. And then we'll take the square root of both sides. So we'll end up with x equals plus or minus 2. So for both of those values at x equals 2 and minus 2, our curve will be stationary. Our last example asks us to find the values of x where the curve f of x equals x cubed over 3 minus 2x minus x squared minus 3x is decreasing. So decreasing means we want that first derivative to be less than 0. So we're going to differentiate first. So f dash of x would be equal to, so 3 times that 1/3, the coefficient, would just be 1. So we'll just have x squared. Minus 2x squared will differentiate to minus 2x, and that minus 3x will differentiate to minus 3. Now we want to solve this, so x squared minus 2x minus 3 is, less than 0 for decreasing. So we're going to factorize this. So we'd have x, and we'd have 3 and 1, we'd have to have minus 3 and plus 1. Now to solve a quadratic inequality, we want to draw ourselves a little sketch. We know that this quadratic would have x-intercepts of 3 and minus 1. We also know that it's concave up. So to see where that parabola or that quadratic is less than 0, it's where it's below that axis there. So we're going to have x is less than 3, but greater than minus 1. So any values within there, our function will be decreasing.